What's up, guys? Ed here with Edward R. Knives, and in the last video, as you saw, we did the topside operation for the CNC knife. In this video, we're going to continue on that. What we're going to do is we're going to flip the stock over like you would if it was in the CNC machine, and we'll go ahead and write the cam operations for the bottom side bevels, as well as the 2D contouring, pocketing of the weight reduction holes, and the lanyard holes. So let's go ahead and pick new setup. All right, we're going to change the box point. We're going to go to this box point because we went ahead and flipped it over. It's going to ask us for the Z-axis. We'll go ahead and do the same thing. Select the edge there. X and Y is exactly how we want it, but it moved on us. So now we got to go ahead and select the box point again. Got X, Y, Z exactly how we want it. We'll double check the body. Let me see, fixture attachment. I'm not sure exactly what that does. We'll play with that later. The stock shouldn't have changed from, oh, I guess it did. All right. Fixed size box, 1.5, 1.875. Change that to 9. Make sure everything is centered. And click OK. And there we are. Exactly how it was before, just on the opposite side. Alright. Let's go ahead and do the same thing. Now we take a look at what we need to do on the knife still. Alright, we saw that we already drilled out the holes, so we'll ignore those. And then everything else is pretty much 3D on the other side. So now we're going to do the same thing, opposite on this side. So, go to Adaptive Clearing. Go ahead and choose the 1/8 inch end mill again. Go to your geometries. We'll uncheck all that. Selection, tool outside boundary. It's really important also right here to make sure that you're selecting the geometry on the correct side, because for some reason or another it still lets you select the geometry underneath. You definitely don't want to do that. So we pick the plunge and the bevel there. Select the bevel up here. Select that, and oh, there we go. And remember, we want to get rid of this, so trash, and we got exactly what we wanted. All right. Let's go to the heights. Looks good. Maximum roughing. Change that to 40 thou. Try to get it close. Stock to leave 20 thou. Perfect. Turn on smoothing. Change that to 1 thou. Making sure that it's ramping down. Alright, cool. Hit OK and let it generate its tool paths. Basically exactly what we saw on the other side. We'll hit simulate. God, if we could only machine that fast, that'd be fantastic, wouldn't it? Alright, so we'll go ahead and close it. What's the machining time on this one? About 3.5 minutes. We'll close that. Just out of curiosity, let's see what the machine time for the top operation is. Well, it's not going to be accurate because we haven't done our speeds and feeds yet, so never mind. Alright, let's go ahead and activate the second operation. Go ahead and change length. back to the multi-axis, flow. We'll select this geometry, that geometry. Select the surfaces. Let me go back, double check the tool. The tool we're going to want to use is the bull nose. Is there an arrow there? No idea. Product link. I'll take you to the website on Lakeshore Carbide. Alright, we got that. Actually, no. Remember, on the other one, we didn't like how it kind of doubled up on the toolpath, so we'll do it as a separate operation. Easy enough to do. We'll deselect that. Passes. I believed we used 30 on the other side there. Let's flip it down, change the direction of the arrow, bring that back to its thou. Looks good. Hit OK. Let's see what it does. Alright, got the bevel. So we'll do it again. Oh, we're getting an error message. What is the error message? Lead radius has been decreased to avoid linking gouge. So basically it's telling us that the lead-in, is that the lead-in? Let's double check there. Lead radius. I've seen this before, and I think basically what it's doing is that it's adapting how it comes in here to not screw up the rest of the geometry. At least that's what I remember it being explained to me. Either way, leave it alone. Should be fine. We'll go to flow. Tool's already selected. Let's go ahead and do the swedge geometry now. Select the surfaces, change the direction, passes. I believe, what do we do? 11? We'll go back and check real quick. We can always edit it if that was wrong. 1 thou. Alright. Let's go back and see. Already passes 11. Smoothing. Alright. Curious why it's doing that warning though. Should be okay. Let me try something. Edit. Linking. Entry positions. See if I can change that. See what it does. Yeah, I fixed it. So instead of coming in at the plunge, right? No, it didn't do a thing. All right, let's see if we can fix that. Get rid of that little. I'm told that it's fine, but it's gonna annoy the hell out of me. Why is it doing that? Transition type smooth, passes. Smoothing. Let's deselect the geometry. I don't know if it does it by order, but we'll change around, see what works. Like I said, a lot of it's trial and error. It's still doing the same thing. All right, we'll leave it. So we've got the bevels done. Okay, so now that we're looking at the stock, let's see what operations are here. So you click on that, click on simulate, it's showing you what's already figured out. So now we still need to do the contouring of the pockets, the lanyard hole, and the contour of the knife itself. So we'll close that out. So let's go ahead. Here's what I'm thinking. We'll go ahead and cut the shape of the knife out last. Let's get these little guys pocketed out. So let's see here. I haven't used the 2D pocket yet. This is the first fixed blade that I'll have done on the CNC machine. I was going to do a contour. Actually, all right, let's try pocket. We don't want to use a bullnose because, like I said, the bottom of the bullnose has a little bit of a radius to it. It's not going to hit all the way to the bottom. It's going to have a little bit of a lip. So let's go ahead and change that. We want to be somewhat efficient with removing stock. So let's go here to find, do I have a 1/4 inch end mill saved? You see it? Nope. All right. Come back to the tool library. We'll go ahead and pick flat end mill 4 carbide. And as I said before, it's a good idea to have all your tools in front of you so you can make sure of the proper height. So I'm going to go ahead and measure my 1/4 inch end mill right now. Got 5/8. Let me change that. 0.25. Flute length is 5/8, which is 0.625. Get rid of that extra decimal point because it seems to be pissing off Fusion. Overall length, I'm using a double-ended end mill, so this one's going to be a little bit long. This is about 2.5 inches long. So we'll go ahead and change that to 0.5. Body length, or we're going to see that's stick out. It's just under an inch. Let me 875. 0.875, 7/8 of an inch. Shaft diameter, right, it's all the same. Good, perfect. Select. All right, let's put this off to the side. Got the 1/2 inch right there. Okay, so now let's go to the passes, or actually let's select to the geometry. So, pocket selections. It's asking you what you want it to pocket out for you. Okay, so you want to select the outline of the hole or the pocket, but you want to make sure you select the correct part of it. You don't want to select the top because then it's just going to run over and it's not going to actually go down in there. So you select the bottom of the hole that you want it to pocket, the bottom of the hole you want it to pocket. And being that we're using an 1/8 inch end mill, this is a little bit too small. I have an idea of what I want to do with this one, so we're going to leave that alone for now. The heights, I want to make sure that it goes all the way through. Selected contours, offset, we're going to go do negative 0.004, 4 thousandths of an inch to make sure it goes all the way down in there. Just as a point of reference, a piece of paper is roughly 4 thousandths of an inch. Actually, you know what? We'll go a little bit further because we have masking tape under there, so that's going to be a little bit of a buffer. We'll do 6 thousandths of an inch. As far as passes go, how many passes do we want? That's a little bit complicated. So let's do this. Let's come over here. How do we want it to go in and start cutting out the hole? We definitely don't want the tool to come straight down into the stock. That's not going to be good for tool life because it's not a drill. If you look at an end mill, it's flat at the bottom, and it doesn't do a good job of eating into there. Most of the work is done in the corner, in the side of the end mill. So we're going to want it to ramp in there, which is exactly what this is. So it's going to, instead of plunging down in, it's going to ease in, utilizing the corner of the end mill to work its way down. So ramping is selected. That's fine. We're going to come over here to passes again, and we're going to want it to do multiple depths. Multiple depths will kind of preserve your tool life a little bit, being that it's cutting a little bit at a time versus the entire thing. So how let's see here. We're going to kind of do some math here. So it's 3/16 thick, 3/16. Let's say we wanted to do 3 passes. So let's see. We have a calculator. Let's grab a calculator. So 0.1875 divided by 3. What is that? 1/16 of an inch. It's maximum roughing step down. 0.0625. Stock to leave, 20 thou. That's perfect. Just because if you take a look, we'll spin it around here. I have this drawn at a 32nd of an inch radius. 1/4 inch will probably come down to here, so we'll leave stock to leave. We'll leave that just fine. Let me go ahead and collapse this so that we can click OK. It's generating the tool path. And you can kind of see now with the multiple depths, it's not going to go through, just plunge and then cut it out. It's going to do it gradually, preserve the tool life. So let's simulate that, see what it looks like. You see it's going a little bit deeper each time. And getting the job done. Cool. Close that. Save it. Okay. Now we're going to do the same thing here. Let's see, 2D. I'm trying to think how I want to do this. We could either do this little lanyard hole here with the 2D contouring. Let's do a pocketing again. This time we're going to use a smaller end mill. We're going to go down to an 1/8 inch end mill, which we already have saved in here. Click OK. Geometry. Pocket selections. Right there. Passes. Do multiple depths again. This time, because it's a smaller end mill, we really don't want to break end mills. It gets expensive. So actually we'll just leave it at 40 thousandths. Stock to leave, that's the same. Smoothing, change that to 1/1000th of an inch. We'll go to linking right here. It's ramping down. Perfect. Click OK to save. And let's simulate that just to make sure it's doing what we want it to do. You can see there it's clearing the pocket for us. I like it. And then we'll close that out. Now, if you remember earlier when we first started talking about the pocketing operation, can't talk. The 1/4 inch end mill, as you know, isn't going to reach into these little corners here. And the way that I have them drawn, actually, for some reason that didn't take. So let me show you what I did. We'll go back to the model space. Go deep into the corners there. Select that geometry. We'll hit F for fillet. Go ahead and select that geometry again. And we're going to do 0.0325. 0.0325 is the radius, 30 seconds of it. It's the radius for a 1/16 inch end mill. So we'll hit OK. We'll save that. Now you can see it's nice and smooth. Why did I do that? I'm about to show you. go back to the cam workspace. And now we're going to do we use a slot? No, let's do the 2D contour. Change this. Alright, so now we're going to have to do some measuring again. I have 1/16 inch end mills, which are tiny. I've never used an end mill this small before. This will be the first time. Hopefully nothing breaks because, well, that's just money going down the toilet and nobody likes that. So we'll go ahead and change the diameter. 0.0625 for a 16th. Grab my trusty calipers. We'll measure the flute length at, what is that? Looks like 288. Just over a quarter of an inch. 288. Now this actually has a shoulder. It actually resembles what you see in the photo here. Actually, let me change that from ball nose. Oh, here you go. So a bullnose end mill, just kind of for reference sake, you can see it's got a little bit of radius there, and that's what's cutting the bevels on the knife. But what we've got with this end mill, it's a flat end mill, so it's perfectly flat right there. Now, it kind of resembles the picture here. The shaft diameter is going to be 1/8 of an inch, so we'll change that 0.125. The shoulder length, which is where it starts to flare out, and the shoulder 0.3325. 325. Stick out. We've got 1/2 inch. And then the overall length is 1.5. Then we'll go ahead and, actually, you know what? Let's go ahead and we'll do this properly. General. /16 inch uncoated. The reason I got uncoated was I bought these end mills for cutting lock bars on a folder that I'm designing right now. Uncoated carbide end mill. Vendor is CGS Tool. Product ID. Let's do this. New window. Go to CGS Tool. Go to accounts. There we go. As you can see, this was just ordered. So we've got right here. Go ahead and search. That's the tool. Go ahead and copy link address. Product link. And then if you remember the item number, it's right there. Cutter, make sure it's all correct. Carbide, inches. Click OK to save it. OK again to actually select it. Now we're going to go to the geometry contour selection. The contour selection is going to be very similar to what we did with the pocketing. So we're going to clear all this out, get it exactly how we want it. We're going to select the bottom there, except this time it's going all the way into the corners now because it's able to with such a small end mill. And we'll select that geometry right there. There's no need for tabs. I'll show you what tabs do later on. Passes. Let's see here. turn on smoothing just to play it safe. 1 thou, stock to leave. No. It's a finishing tool. Multiple depths. Yeah, we'll play it safe. Lead in. We want it to ramp. We'll try 30. Let's see how that looks. I think we got everything figured out. Click. Oh. We'll change the bottom height. Again, 0.206 for 6 thousandths. So you can see here what it's going to do is it's going to come in and clean out that inner wall. It's a lot of operations, it's a lot of work, but we want to do it right, so try to give ourselves the best chance at a nice clean finish. See that geometry there? It's doing the lanyard hole, and now it's doing the front pocket. All right, fantastic. This is going very smooth. Go ahead and save that. So now, let's take a look at what we did here. This is everything that we've done so far to the backside. So now we got to cut the knife out. So what we're going to do for that, come back up here, 2D contour. You definitely don't want to use a 16th inch end mill. Yeah, that's not going to be fun for anybody. So there's a couple of ways that we could do this. I have a tool that's a roughing tool. It's the fire plug end mill, 3/16 inch fire plug. My buddy Mike over at Ecom Knives. If you haven't followed his channel yet, definitely do so. I learned how to make a chef's knife watching his channel. He also walks you through how to design and make a folding knife, a frame lock folder. So definitely check him out, Ecom Knives on YouTube. He told me about a tool over at Lakeshore Carbide. It is called the Fire Plug. Let's go ahead and pull it up here. Lakeshore Carbide. Is it under knife making? No, we'll go up here. Fire Plug. There we go. This is a great contouring tool because it not only is an end mill, but you see those little grooves there? That breaks your chips up. So it's going to make it a lot easier on the tool life. If you're getting through tough material, it's making it easier for itself. Kind of difference between, say, a smooth end mill where the flute's nice and smooth like a knife. This is kind of like a saw. So, yeah. I'm not sure if I want to use that in this instance just because of how tight of a tolerance I have with the stock running into the back rail. And you know what? Yeah, I'll go ahead and do that. All right, so do I have it saved in here? Photos, no. Library. I don't have it saved. All right. I know I have it in the library, so let's come over to this space over here. What's the knife that I did? Let's see. Could have sworn that I've already done the cam setup on this. Top milling. Okay. So now it should show up. What's that? 2D, so we'll have to select it again. There we go. I've already got it saved. Fire plug, product link. Let's go ahead and edit it. It's got it saved as high-speed steel. which it is definitely not. Everything else is the same. Contour, yes. Save, okay. So we've got the tool in there. The geometry, contour selection. Again, you want to select the bottom outline, not the top. So I'm coming over here, selecting that. We'll take a look at an overhead view to make sure it's got it correct. Let me move this out of the way. Looks about right to me. Heights are the same. Passes. Oh, actually, here. Tabs. We definitely want tabs because we're going to be using either CA glue or Mighty Bites. I haven't quite decided yet. You don't want the knife just flying out of there, right? The pocketing, we didn't need tabs because it was actually clearing out from the middle going all the way out. With this, we are just cutting the outline. We don't want it to get most of the way out, and then when it clears it out, it's just going to throw the knife. Nobody wants a knife thrown at you. It's definitely a bad idea. So the tabs, you can either do it by distance, or you can pick the points that you want, which you just kind of select the geometry. This looks pretty good with the distance. Let's double check to make sure that the heights work for us, though. So here you can see it's just under the bevel. So these two aren't really doing anything, and these two aren't doing anything. So we'll change the height. Let's see here. We'll go back to the calculator. 3/16, which is 1875 divided by 2. We got 0.93. We'll change it. We'll round it up to 0.95. 0.95. So now, if you come over here, you can see that even though the bevel and the swedge is already cleared out, it's still holding on to something. It's not just going to fly out of there. And it's going to keep it nice and rigid for us. Same thing with over here. Let me play with it, see if we could do a triangular so that it's a little bit easier to clean out. We'll save it as rectangular, just to play it safe. Come back over here to the passes. Get this up here so we can all see. First thing we're going to do is we're going to turn on smoothing. Collapse that tab. Multiple depths. Actual roughing step down. I mean, this is a roughing tool. You can get pretty aggressive with it, so we'll do 2 passes. See how that goes. So 0.095. Will that get about half? I am horrible with math. Sorry. So we'll check that. 0.1875. Yeah. 0.95. So we'll do 2 passes. Stock to leave. No, we want it to go all the way to the edge. Linking. We definitely want it to ramp down because, like I said, it's a flat end mill. It's not good at plunging. You can see there how it's going to enter in. It's just going to use the corner of it to break down in there, and it's going to do the job that you want it to do. Lead in sweep angle. That's how it approaches the model. All right, it all looks good. Click OK. And we can go ahead and run the simulation. All right, watching this, let me change that. So the problem with the rectangular tabs is that you can see that once it clears the tab, it wants to plunge straight down. Just for the sake of preserving tool life, we'll go ahead and change that to triangular. But we can go ahead, yeah, that looks about good. Should we make that a little bit higher? Yeah, let's make that a little bit higher. How does that look? Perfect. That's generating. So now you see what it's doing. Instead of, it's going to ease out, come around. Instead of just dumping it down in, it's going to ease it down. Run the simulation again. Zoom out so that we can see the total picture. Start the simulation. And it looks like it's doing a pretty good job of getting the knife done. And there you have it. Looking at the time that I've been recording now, we're a little bit over an hour. So the speeds and feeds, we'll have to do it as another video, just because, yeah, we're not trying to watch a motion picture here. I might even break this up into two halves, the top side and the bottom side. But yeah, there you have it. We'll go ahead and click on setups. Click on simulate so you can see everything that it's getting ready to do for you. You got both the bevels, both sides of the swedge, the pockets, the holes getting drilled out, and then lastly the contouring. As far as the speeds and feeds go, it's at a pretty ridiculous pace that Fusion has as its default, but just out of curiosity, 21 minutes. That's really ambitious. Realistically, we're probably looking at, I'm going to guess about an hour once we have it figured out. So, all right. So that being said, we're pretty much done with the tool paths here. The next thing we're going to do is work on the tool paths. And what we're going to do here, gee wizard. So you're going to come into the CNC cookbook, download, set up an account. It's free for 30 days, which is ridiculous. It's free for 30 days, which is a ridiculous amount of time for a free trial. After that, you're looking at, where's that? Come on, load up. No. Let's try this again. There we go. After that, it's on sale, so you're looking at about $70 for the year. If you go to start my free trial, you have 30 days for free. If the page would actually load up. Either way, check it out, cnccookbook.com, set up an account. Once you're there, we'll go ahead and do another video on how to figure out speeds and feeds. But in the meantime, let's go ahead and end this video because it is running really, really long. So, if you guys have any questions, feel free to leave me a comment or shoot me an email, edwardrknives@gmail.com. If you guys are looking to kind of follow through and make a knife along with me as I'm learning this, kind of like I'm sure a lot of you guys are as well, make sure to subscribe. I'm going to try to release videos on a weekly basis, if not every other week at the worst case scenario. But yeah, I'm pretty much attacking each aspect of knife making. You know, I built the forge. I'm learning bladesmithing, which I'll have videos on that, as well as CNC knife making. So yeah, follow along on the journey, and hopefully we all get this figured out together. Thanks for watching, guys.